All right. Good afternoon, everybody. So, what we got to talk about today? We're going to take a little detour here because I want to get this distance formula and midpoint formula in. So, how can we find the midpoint and the length of a line segment in a coordinate plane? We're going to look at the length first. What we're going to do today is what's called the distance formula. Come on. There we go. So, in order to do the distance formula, we got to just think about the Pythagorean theorem. Now, you all know the Pythagorean theorem as c squared equals a squared plus b squared, but it's actually the square of the hypotenuse of a right triangle is equal to the sum of the squares of the legs of the right triangle. All this is saying is in words what you've known all your lives as a squared plus b squared equals c squared. The square of the hypotenuse is opposite the right angle, so the square of the hypotenuse, c squared, is equal to the sum, add together, of the squares of the legs of the right triangle. That's all the Pythagorean theorem is, but these are the words that go with a squared plus b squared equals c squared. Now's the part where you're going to have to pay close attention. The distance formula comes from the Pythagorean theorem. Think of the length of the line segment we're trying to find as the length of the hypotenuse of a right triangle, right? We got to think of it that way. So if I want the distance of AB, I want the distance in the coordinate plane. Now, I didn't put a plane in here. We will eventually put a coordinate plane. Coordinate plane is what? The x and y axis. We'll have a point. We're going to find the distance, right? That was a horrible line, but you get the idea. But just to get started, let's take a look at this diagram here in detail. So I want the distance from A to B, the length of AB. To get that, I got to think of this as a right triangle. So I have these two sides that I drew in. The blue dotted lines, dashed lines, don't mean anything except to show that this is a right triangle. And if it's a right triangle, then I can relate the C, which is now my distance, colors, there we go, C, which is now my distance D, right? So C squared equals A squared plus B squared. D squared is equal to, well, let's take a look at that. Earlier in the year, I defined very early on in Tools of Geometry the distance between 2 points. The distance between 2 points is the absolute value of their coordinates. So let's look at BC, right? Side A is BC. So BC is the same as side A. It is the distance x2 minus x1. Well, where do those come from, Mr. Castro? Well, let's look at point A. Point A is at some point xy. Remember, in the coordinate plane, everything is some number, 3, 4, wherever it might be, right? But right here, A is at some arbitrary point x1, y1. Now, these sub numbers, the ones underneath, they're just placeholders. That's just telling you I have more than one x and more than one y. So at point A, I'm at x sub 1, y sub 1. That's how we say it, or x1, y1. Doesn't mean multiply, it doesn't mean powers, just telling us that I have my first x and my first y is at A. Well, let's look at B. B is a different x from this one, correct? It has to be. It's over here. It's a different y from this one, correct? It's over here. So B, my point B, is at some different x, which means it's x2, some different y, which is y2. And point C is a combination, right? I'm at the same x as A, so that's x1, but I'm at the same y as B, so that's y2. So these are just our 3 points. Arbitrary points They don't mean anything yet. They're just placeholders. As I said when I started this slide, the distance between 2 points is the difference, absolute value of their coordinates. Now, you can only do this with horizontal and vertical lines. I can't just say x1 minus x2 is going to be the x coordinate of B and y1 minus y2. However, over here, A, this side, this is a horizontal line. This goes along the x's. The length of BC is x2 minus x1. The difference of the x's, absolute value. So now I know that this is the length of this side. Up and down, vertical, that's y's. So this length here is y2 minus y1, which is b. Follow along with me. C squared equals a squared plus b squared. We know that's the Pythagorean theorem, but our c is d. So d squared is equal to, we know a is the absolute value of x2 minus x1. B is the absolute value of y2 minus y1. So a squared is x2 minus x1 squared. B squared is y2 minus y1 squared. But I want the distance. So in order to get d by itself, I take the square root of both sides. Taking the square root of anything squared just gives me d. All right, great. I've got d now. Distance is equal to square root. Since I took the square root of the left side, I have to take the square root of the right side. x2 minus x1 squared plus absolute value y2 minus y1 squared. But look down here. I don't need the absolute value symbols in here. Why don't I need them? Because when I square any number, it becomes positive anyway. So it doesn't matter how I subtract here. As soon as I square it, I get a positive number, right? And be very, very, very careful. Negative 3 squared is not the same as negative 3 squared. This would be negative 9. This would be positive 9. So take the number in here and square it. I get a positive number. This is the distance formula. This you have to memorize. I just went through the steps of how we got the distance formula, how we obtained the distance formula from the Pythagorean theorem. Distance formula, d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Couple of examples. Find the distance between these two given points. I always find it helpful to label x1, y1, x2, y2, so I know what to put into the formula. So now we're talking about a specific distance here. So I'm going to write CD is equal to, not D, I know the distance formula. You can always start with the distance formula in general first. In fact, I think I will do that. Oops, let's see. Copy, paste. It's not letting me paste it, so all right, so whatever. So D equals square root, parentheses, x sub 2 minus x sub 1 squared plus Copy, paste, change that to Y. There we go, right? So that's how I'm going to start. But I know D is not D, it's CD, which is what we're looking for, equals. I'm going to move this out of my way. Let me put that in there. Square root of, now what do I have? X2 minus X1. Negative 3 minus, be careful here, negative 6. Plus, what's the difference of my y's? Be careful. If I go from here, right, I started here, I want to always start here for both pieces. So 1 minus 5. 1 minus 5 squared. Enter. GD equals square root of. Now, what is 3 minus negative 6? That's negative 3 plus 6, which is going to be 3 squared. Plus, again, be careful here. Negative 4 squared, right? Which equals the square root of 9. Now, negative 4 squared is positive 16 plus 16, which equals the square root of 25. Which equals 5. Oh, the distance, CD, is equal to 5. There's another one here for you to try. Now, on your homework, there is some where it says your answer should be in simplest radical form. I haven't gone over that, but I included a video, a YouTube video on how to simplify square roots. So if you need help doing that, that does not mean to a decimal. It means simplest radical form. All right, so that was it for today. You can try this one on your own as well. I'm not going to do it with you, but the rest of your assignment will be on Delta Math. Have a great day.